Thanks, Tanya. Now I know I'm between you and lunch, so I'll try and make this quick. The thought of this talk started last year. Is that too loud? I feel like I'm punching out. That's good? Cool. This all started last year at this conference when Graham Foster did a 5-minute lighting talk challenging the theory that monoliths are bad. He got up and sort of did this neat little rant. So yeah, Graham challenged what's wrong with the monolith, and that made me start thinking and paying attention. And I noticed that our young developers were making a movement. They wanted to adopt microservices, and those microservices they wanted to be in their own GitHub repositories, which was interesting. But then old devs like Graham, James Miles, Matt James, who you guys might know, were actually asking the opposite question. Why do we have so many repositories in our team? Why is it that when we change that thing, we also need to open up that repository and change that thing? Hey Lee, what do you think about just sticking it all into one repository? And I've had this question asked a couple of times, hence why I thought this would be an interesting talk to do today. And so like Corey, I'm going to do my walk down memory lane bit. So remember when, some of you won't because you weren't born then, the late 90s, early 2000s, Bill Clinton was the president. And we had these revision control systems. Some of you will giggle, some of you will just blank and not know what these are. Visual Source Safe was my source control or revision control system for the first 4 years of development I did. It's a pessimistic, centralized system, so if I want to edit a file, I need to check it out, lock that file. I've got a write lock on that, which is kind of weird, because looking back, I'm not sure why we just didn't have a network drive and take actual write locks on the files. And then Subversion came along, and that was optimistic locking and introduced branches, but now you had branches, so you had merges and merge conflicts. And we used those revision control systems to deal with these languages. And what were we building? Mainly websites. It's .com boom time, so we're knocking up websites, but there's also no end of accounting software and point of sales stuff coming out at the time. And this was happening. Mum was saying, surf the web, so you know that that was all dead. People were writing mashups, but once you'd written the second developer had written the maps plus restaurant rating mashup. All that was left was to write books about writing mashups, because the one mashup was done. We talked about building systems like this with our presentation, business logic, persistence, data store, but actually we built things like this with the persistence business layer, which is kind of neat because we just saw something similar that was a successful weather app and shamelessly doing the same thing. So hacker life, right? So thanks for the walk down memory lane, old man. But the reason I'm telling you this is for the old boys, a reminder of how we got to where we were, and for the young people, just to illustrate that's what we actually lived with to get to where we are now. And something I haven't mentioned is that it wasn't until 2001 that we had our first CI, or continuous integration server. Cruise control came out in 2001. That wasn't any use to you unless you were a Java developer, wrote unit tests, and liked open source software, which is pretty much no one, right? Back then, open source software was as weird as your neighbor's ICO, right? It was, you didn't want to be touching it. So without a CI server, how did things get built? How did things get deployed? Well, it was the simple days. Most of the stuff that I worked on, at least, was just websites, server-side scripting. So you would just X-copy it. If you were on the network, if the web server was on the network because you would have your own data center, you just dragged and dropped these ASP files over there, and that was the deployment. If it wasn't on the network, you just FTP'd them across. If you wanted to roll back, you just renamed root to old and renamed old to root, and good, rolled back, right? We laughed, but it worked, right? It was fucking stupid, but it worked. And repositories, going back talking about Visual Source Safe, Subversion, everything just lived in the repository. I was at a product company for my first 2 gigs, and the repositories were just divided up by our clients. So we'd have L'Oreal here, Repco here, and if you worked for the Repco team, you just worked in that one repo. At other places like banks or insurance companies, you would be split up by department, and you just open your repo, and that's the only thing you ever looked at. Life was pretty simple. If in a big company like a utilities thing, they wanted an integrated system that warehousing could talk to pricing, could talk to marketing, generally what would happen is that they would have an ERP system in the middle of everything. But Gregor's Enterprise Integration Patterns book sort of pointed out that scaling was an issue if you shared a database. With this ERP system in the middle of your large company, you couldn't just point your e-commerce site directly at that database. They were too tightly coupled. Someone updating pricing, and Mary's updating the pricing, she could bring the website down because that transaction was just too heavy. Or we could have people hitting the website and bringing the ERP system down. So you don't want to share a database. And also, like for an online bank, you wouldn't point to your online bank directly at your mainframe. So this started the, in response to that book, I think SOA, Service-Oriented Architecture, emerged and talked more about message passing and system isolation. And then came an era I call engineering envy. So we had a couple of white papers come out, and then all of a sudden, every mum and dad pet shop website had the same crushing problems as Google and Amazon. Pet shop, your local pet shop website could only work if we had elastic compute and MapReduce. And I see this sort of carry on today where people think that they have the same problems as the company that serves 25% of the internet traffic in the US, or the company that invented the fail whale. So where does that leave us? I'm kind of going to be a bit antagonistic and divide the world up into 2 things because it makes my life easier. So we've got enterprise developers, and I quite like that term because if you refer to yourself as enterprise, it's like a badge of honor. If someone else refers to someone as enterprise, it's normally a badge of shame. Sadly, I think I sort of fit in the enterprise developer world, so a bit weird. But enterprise stuff, banks, insurance companies, utilities, all that kind of stuff, generally was .NET Java. Multi-module support, so if you know .NET, there's a solution file, a lot of CSproj or VBproj, FSproj files. And you can have many things built. You could produce multiple XEs, you can produce multiple libraries. And same thing with Maven, you've got multi-module POM files and things like that. And it actually makes it really easy to just jam everything into one repo. So that worked really well for the department, everything goes in the repo, or for the client, everything goes in the repo. And then build servers did start coming out. We've got cruise control, we upgrade to TeamCity and Jenkins, but these things become sort of snowflake servers. So now we have the downsides to the enterprise repository was merge conflicts. That solution file, that POM file, that CSproj file, everyone's trying to access it, so you're getting merge conflicts. That's a pain in the ass. And you've got, but you do have, you've got a high cost to build, and you've got a single technology. So generally, if you're with Java or Java 8 or .NET Core, the move to something else is high friction because generally the whole repo has to come for the ride. Build servers were often locally hosted, so download, click, install, use your mouse, and then they became snowflakes and only one person really knew how they worked. But the benefits were clear. There was a single place that you would go to do your code. There was a single place you'd go to build. And the output was normally a single thing. Even if it was multiple files, it was a single logical thing, and you would deploy that. And I kind of like the bear as the metaphor for the single repo, single deployment model. Big, powerful, and simple. Not bear, sorry, Kiwi, I can't say my words. On the other hand, you've got the startup developer, so .com boom's happening, big companies moving big and slow, Java.NET, or not even .NET, just Java back then. And then you've got the other end, the startup developer, heavily favored agility and delivery and value over everything else. That led them to strongly favor scripting languages, Groovy, Ruby, Python, PHP, and we saw JavaScript rise as a server-side language. Some places did pair program with hot reloading for unit testing, which actually, it was interesting, diminished the need for a build server. If you're pairing all the time and it's hot reloading your tests, maybe you don't need a build server. But we did see hosted cloud build servers start appearing, Travis, Circle CI, AppVeyor. And this is great because now config for the build server lives in the source code, not in that magic place on the hosted box somewhere. So initial disruptors to the old way, these startup people, generally back then, were actually only really building marketing, blogging websites, maybe a mashup. The value of the stuff that I saw with what they were doing wasn't so much in the software, although the software may have been good, was actually in the process, the design process. They were experts generally at UX and agile software practices. MVP thinking is quite a different way of thinking to how an enterprise developer worked. And so now you get this tension. We've got enterprise developers trying to add value at the speed that the startup guys are. And then you've got the startup guys trying to actually start creating more sophisticated software. So not just a mashup or a blogging thing. How can we build something of higher value like the enterprise guys are doing? Then we also saw the pushback on the weight and friction of SOAP, WSDL, UDDI, Oasis, Destar. The idea was good, but they were heavy, and it got very confused about what SOA was, what web services was, what SOAP was. It all just felt like it was the same thing. So as SOAP and web services died, SOA went down with it. And so what we did was swapped out for microservices, so that's come along, and we've swapped a verbose text human readable format for a verbose text human readable format. We swapped SOAP, a protocol, for another protocol. I think that's definitely a big jump. We've got rid of the ESB and put in a bus. Okay. With SOA, we knew that the data was always behind the service, it was inside encapsulated. With microservices, half the people I ask, are you doing microservices? They say yes, and then I say, and do you share data? Oh yeah, we've just got one database. So we've swapped a confused understanding of SOA for a confused understanding of microservices architecture. One of the key drivers for MSA, microservices, is agility. We want to be able to deploy independently, which means the repos, should they version independently as well? Now we have to balance the size of a repository to be autonomous, but also small and fast. So now we've got this balancing thing we have to do. JavaScript, TypeScript, Go, they seem to be the languages of choice for the microservice developer. Interestingly, they also generally only produce a single output. They don't do multi-module stuff well out of the box. So these small repos that are possibly a Fred George style 100-line of code microservice, I think fit a nice metaphor of the ant. They're small, they're task-orientated, and they make up a sophisticated community. By themselves, not so useful. Put together, now you've got a community or a sophisticated system. But now we have this weird bipolar view of the world. We've got monolith, or mono, and at the other end, microservices, or nano. And I think this is where teams really start to struggle. If you're an enterprise dev, you know that this is big and hard. The 45-minute build process is just exhausting. You're stuck on Java 7 or 8, and you want to get to Java 11, but you've got to either work all weekend to do the mega pull request to upgrade everyone in the bank to Java 11, or you just give up and just don't. You stay on Java 6 forever. And then you've got the far end. It's like, now I have to get to microservices, which is these tiny little things. So are monos bad, or are they good? So following up from Graham's proposition from last year at Latency Conf, are they good or bad? Now I'm going to just lump monoliths and mono repos together very casually, and I know some people are going to be like, hang on, they're not quite the same thing, but for today I'm just going to do that. So it was interesting, same thing with Corey did his, the old is the new thing, Clippy's back, but he's just called a chat bot now, right? I had a young developer the other day say that we will only need thin clients moving forward because of 5G. You will not need to install any software, and he said it without a hint of irony. If you've only been in the industry 5 years, you haven't seen the 10-year cycles that happen. Centralized versus decentralized, thin versus fat, Clippy's back, composite app versus application suites. The software developer community doubles every 5 years, but after doing something for 5 years, you feel like an expert. But you haven't seen the 10 years of what's going to happen again. So the challenge with the young ones, they challenged the mono repository. But what is the mono repository? This is what I was doing for the first 10 years of my career, but we didn't call it that, it was just work, right? With the mono repo, you don't have the contract version dance. If I want to update a contract, I don't need to go to that repository to change that and then get the build output and then apply it to these other repos. It's all in one place. I've got build certainty. When I build it, I know that the thing works. I don't have to cross-build things. There's less duplication, and more importantly, Facebook and Twitter and Google do it. They've got the mono repo, the big thing, okay? And then there's an interesting question, monstrous mono or project mono repo. We'll talk about that in a moment. So the issues with the mono repo is that Facebook and Google have dedicated teams to dealing with this huge repo. They've also hacked Git and Mercurial to make it work. In your smaller company down here in Perth, you're probably going to have to do some magic build scripts to split this thing up, or you have to build everything. You're going to have a slow deployment. And we've also got that friction to change. So something worth considering with your mono repo is that cost-benefit trade-off to a mono. So what other considerations are there? Are you going to go with a company-wide monstrous mono repo, or just the project/department mono repo? Will your language be able to support it? If you're doing JavaScript, will you have to get something like Git submodules or Learner to apply and do a little hack to work around how natively JavaScript works these days? What's your versioning strategy if you're going to have the big mono repo? If just that bit changes, do you version everything together, or do you have some sort of versioning strategy or a manifest file that goes inside the repo? That gets really confusing with branching and distributed version control systems. Now, at the other hand, we have serverless or nano services or Lambda architecture, highly testable units, optimized for elasticity, and it's the natural evolution of this shared nothing model. So now, instead of having a big fat repo, you've got many repos, and now you've got a new problem, which is integrating and managing all of these things. Integration is hard, but you can end up with that old effect, like each repo kind of worked, but putting it together is just a little bit harder to do. The more common issue I see with a mismatched repository size is that when I change one repo, I also have to do the other thing. If you've got 3 IDEs open to do one thing, that might be an indicator that you've got a mismatch of repository sizes here. So at one end of this continuum, I think we have the repo just for your Lambda. Maybe that's a bit over the top, not so much for me, but it might work for some people. I think a nice example of the Lambda architecture is the Have I Been Pawned website, has my password been stolen? I think that would be probably a good candidate for having Lambda repo kind of things. I'm not sure how Troy does do it, but I think that could work. At the other end, we have the monstrous repo. That's what Google, Facebook are doing. Personally, I would leave that to Silicon Valley if they want to do that. However, we have already seen today someone talking about their whole code base was like 500 lines of code. Why would you split that across multiple repos? That seems perfect for a single repo. And I know there is an Australian startup that had all their development done in WA. They've recently featured on primetime TV. They're doing very well, and that's a shameless mono repo and a monolith deployment. It's working fine. Then we have the project repo, and this is probably where you would want to start, I think. If you're starting a project, don't guess too far ahead. Project, we're going to build global poker. I'm just going to create the global poker repo and figure out what I'm going to do from there. The trick there is not to back yourself into a corner. Is to make sure that if you decide that this is too coarse or too fine-grained, that we can pivot. And then I think we've kind of got the unmentioned alternatives. I don't think we have to think it mono versus nano repos. If you follow DDD, anyone domain-driven design Couple of hands, cool. You would know what a bounded context is. You can model your repos and deployments around these bounded contexts, and that gives you a really nice sphere of thinking. Things that live together in this model are likely to change together. That's a really good way of thinking about where code should live. If it lives together, it should change together, or vice versa. If it changes together, it should live together. So in one repo, you might have your provisioning, your data scripts, data store scripts, your command API, your read model populators, your query APIs, and potentially some process managers, all in the one repo. Now, there's a few services there, right, but you can put them all in one repo. Slightly more fine-grained than that is what I would refer to as the microservices architecture, and that might only include the triplet, which to me I would call them the producer, the filter, and the collector, if you're following the rapids, river, ponds architecture. Ring any bells? Fred George kind of style? Yep. I think these DDD or microservice style repos, microservices style repos, I think a wolf pack is a good metaphor here. A wolf is effective as an individual, like a bounded context. You could write a bounded context for the warehouse part of your company or the marketing part. It can work autonomously by itself, but when joined together with sales and inventory and pricing and shipping, now you've got a really effective system. And that's where I think the wolf metaphor works. As a pack, the wolves are more effective, but they're fine by themselves as well. So we have a continuum to evaluate, not just a binary choice to make. We've got trade-offs between build times, agility, cohesion, coupling, and developer productivity. And that isn't to say that the ants will give us the most agility or less agility. An example might be, if I want to try out a new style, so I want to try Golang, then the Ant model works really well. I can just spin up a new repository or have an existing one and convert the language. That's a good low friction experience. However, if everything's written, for example, in Java, and we find there's a vulnerability, now I need to go and update 40 repos to fix that vulnerability. So there's some trade-offs we need to think about. And I realize I'm not giving you concrete suggestions, and that's what most people want. They want a silver bullet for this kind of stuff. But the goal of this talk is to promote discussion, to have people question their current state. So if your build times are longer than 5 minutes, 5 minutes, anyone here got build times longer than 5 minutes? Ouch. Like, that's not cool. They can be quicker. Like, it's 2018. You should be able to mine 3 Bitcoins in 5 minutes, right? If your build times are longer than 5 minutes, if you haven't upgraded to the latest language version because of friction, like not because your server won't handle it, because it's just like, oh, that's going to be a real messy update, or your life is just merge conflicts, I think you should challenge the size of your repository. Just like your AWS accounts, that's the new repository. We're talking about reducing our blast radius. We've got one giant AWS account Corey was talking about. How many more do we have? Too many, too little. We want to find the Goldilocks number. Now, at the other end of the scale, if you always have 3 IDEs open, who always has more than one IDE open? Maybe you've got too many repos, right? And this is super weird, because I've worked at places where we had 45-minute build times, but I still needed 3 IDEs open. Somehow we just landed right in the middle of the worst of both worlds. So I think that's another thing that you can challenge. If you've got 3 IDEs open, the things that change together don't live together. I think you've got a mismatch of boundaries there as well. So in that case, challenge your ants. Okay, that's all I've got for today. I'd like to thank Alvin for doing the graphics and thank Macroc for running the conference today. Cheers. We've got